In this segment, I'll talk about how to test for the significance of an indirect effect. There are a couple of ways, and then the second part of the segment, I'll talk about power to detect mediation. We've talked already about the magnitude of an indirect effect, but we haven't talked about whether it's significantly different from zero. And so that process requires either the Sobel test or bootstrapping. And so the Sobel test is just a simple z-test where we have the indirect effect on the numerator and then the standard error on the denominator. And so this is just not complicated at all, and there are some computer programs that will give you the Sobel test. In fact, most will. And you can Google the package in R that will give you the Sobel test. I'm sure there is one. And you can calculate that Sobel test for the expect data that you have. Now, bootstrapping is the better way. And so if you do report the Sobel test, it's really important to report the bootstrapping as well. But you can report the bootstrapping and not the Sobel test. So the bootstrapping is the important one here. So, having said that, it will depend on what your audience wants. So sometimes you will have people ask you for a Sobel test still because it was the older way of testing for the indirect effect significance. Now, bootstrapping, I've explained this before, but I think it's important to go over it again. Conceptually, I want you to know what is involved. Basically, what goes on behind the scenes is your stat platform, and you can program this into R fairly easily. Get someone else's code and work with it, I think, is the first maybe step to doing this if you wanted to try. But basically what bootstrapping does is it takes your data, where you have this mediation you're proposing, takes all your data, and it creates a huge population from your data set. And that population has very specific attributes. So it has the same mu's and it has the same sigmas as your original sample. And so that creates a huge pool to sample and resample from, basically. So then what the computer will do, and this is why bootstrapping takes some time, because you'll see in R like it's running for a while sometimes. But it will sample however many thousands of times that you indicate. So you can do 5,000 samples, you can do 1,000, you can do 10,000, you can do whatever you want. And I think 1,000 is probably sufficient. 5,000 is kind of the, I think, limit that most people do for publishing. But anyway, what it does thousands of times is it takes a sample of the n size of your sample. So if you had an n size in your study of 350, then out of that big population, it will take 350 randomly out, and it will calculate the indirect effect on that sample of 350. So it'll take the A times B paths on that sample, and it will throw it back in. So this is sampling with replacement, and then it randomly pulls 350 again. And it will do that again 5,000 times, however much you specify. And then all of those A times B paths, it will take the mean of those. And that is going to be your estimate of the indirect effect in your study. And that's what you'd report in your journal or in your presentation. Right? So it takes all these indirect effects, averages them out. And this is supposed to be much more stable than the one that you have in your sample. Now, ideally, if you have an adequately powered sample, I think most of the time, at least in my lab, your observed indirect effect in your sample and the bootstrapped one are not that far apart. And that is a great sign. Where you start to get the discrepancy is where you have just a small n size for your original study, and that could be a problem. But most of the time, I've never had an issue with this. Now, what bootstrapping does is it gives you that average effect size, and then it creates CIs around that estimate, that average. And so what it will tell you is that 95 or 90, again, you can specify the width of that confidence interval. 90%, let's say, of the bootstrap samples fell in this range, from this to this. This is the smallest and this is the largest. And if that range contains 0, if it's like a negative to a positive indirect effect, then we know that that is not a significant effect. The indirect effect is just not significant. At P is less than, if it's 90.1. If it's 95, P less than 0.05. And so that is what you'd report. If this indirect effect, the CIs for the bootstrapped intervals are not, it contains 0. If it contains 0, then we know it's not significant. If it does not contain 0, then it is significant at the p-value cutoff that you chose, basically. So both of these methods are pretty legit, the Sobel test and bootstrapping, but it does depend on your audience. I would do the bootstrapping. It's very easily done in R and other programs as well, and you'll learn all about that next quarter. Now moving on to power. Power to detect an indirect effect depends on a lot of things. And for this, I always reference Fritz and McKinnon, and that's located in the notes below the slide. This is an article that they did a lot of Monte Carlo studies in order to really understand when are you getting when are you getting significant indirect effects? At what number do you need? And that depends on the size of the A path and the B path. So I will show you that here. So what we have on page 237 of this article is a table. It looks like this. I'll make it bigger. And here's the issue with mediation, is that if you expect to see a tiny A path and a tiny B path, then you need a lot of people in your sample to detect that. Remember the small effect size, you need more people, you need really reliable measures, you need all this precision. But if you have a large effect on the A path or B path, or both, ideally both, you need the least amount of N size. All right, so I want you to not worry so much about all of these, because they did the Sobel test. They did the Baron and Kenny method and the steps. And I consider these completely out of date. But the bias-corrected bootstrap is what is normally done to test. And there are some corrections that the STAT platform makes in the background for bias correction. And I think the percentile bootstrap is just the one that I explained to you. It's the very simplest form. But either one of those, I think, are generally used in the test of mediation in the field currently. Now, in their Monte Carlo, they varied the size of the A path and the B path in order to understand using the method of bias-corrected bootstrapping, what kind of N size will we need? So the SS just means that both the A path and the B path have an effect size of 0.14. And this is standardized, so this is a beta path, actually. Or the beta on the path. The high or the H, I think, is like, it's not high, sorry I said that. It's it's like one step up from low, actually. So I forgot what the article said the H stood for, but it's fine. Don't worry about that part. Just know that 0.26 is the beta that's represented by H. And then M is 0.39, and then L is large effect at 0.59. Now remember I said before in this class, I just assume small effect sizes all the time, because when I look at the literature, I know those are probably inflated and things like that. So I just assume small effects unless there is an experiment that you've pilot tested that IV. And so you can assume the A path is going to be a little bit larger, because an experiment usually makes an effect size larger if it's an effective manipulation that you've pilot tested. So maybe you believe your A path is going to be more like 0.39, but your B path is going to be small, 0.14, if you have an experiment and you're manipulating the IV. So as you can see, they have all of the different combinations up here indicated by the columns. And by the way, all of these are sample sizes needed for 0.8 power. So if you wanted 0.9 power, you're going to have to make all these higher, right? So as you can see, having a small effect on both the A and B path is going to be most costly, because you're going to need 460 some, for percentile 550 some. But then as you get larger effect sizes on one or both paths, you're starting to see more reasonable numbers, which is wonderful. So this is the one that I always go to. It's the most recent one at the time of this recording. for citing to justify the sample size that you chose. And yeah, so this is the one that you go to, and I think the hardest part of this is estimating what your effect size is going to be a priori. Prior to conducting the study, what's it going to be? And like I said, I just default to lower usually, but that's going to be costly for sample size, so I understand when people, want to assume it will be more, and then you're getting into more of the 150 instead. And look how wildly these vary. Just between, like, for example, 368 versus 148. This is a little bit of a rabbit trail, but when both paths are the H size 0.26, then 148. But if it's just one path that's 0.26, the H, then we have, yeah, that is a lot more. That's like doubled. And so anyway, this provides a guide, and I'm sorry I can't deliver better news in terms of paying your participants and proposing a mediation. But at least at the time of this recording, this is what we know. And once again, the facts of the matter are agnostic to our feelings. If this changes, let me know. If you see one that is more current, I would love to see it. All right, let's move along to our next topic.